do it, and during the nighttime I like hacking on Ripple and Bitcoin and other stuff.
Hi, I'm Manjunath. I basically work in a content management space in the daytime, and I'm trying to understand the Bitcoins and other technologies and trying to learn new things.
Hi, I'm Ajit Ahuja. I work at an institutional asset management firm. I'm a software engineer out there. It's been a great experience learning Bitcoin and Node.js.
Hi, I'm Subra. I'm a consulting professor. Also, I do some work in strategy and technology consulting.
All right, so so what we were trying to do was create a loyalty program that sits on top of the Bitcoin network. And the way we saw it working is, so the user doesn't even need to be aware of the whole thing. A merchant can go sign up to hashloyalty.com and say, hey, here's my public address, and actually create rules, right? So if you spend more than $100 or 100 Bitcoins, give back 1% or 2%, right? And so we tried to build a couple of features around it, and obviously we weren't able to put everything together, but the idea is now, let's say the merchant comes and says, okay, here's my address and I want to give 1% or 2% back, right? So what we do then behind the scene is go look at all the past history for a year or a month and see, hey, if you do this promotional program, here's your potential liability, right? So that the merchant gets a sense of, hey, should I do a 2% cashback or a 3% cashback, right? So that's one of the things of the rules, and then what happens where, so let's say the merchant does that and creates a rule, and then behind the scene, the service will be constantly monitoring the blockchain transactions, and as soon as we see, once the time limit hits or whatever threshold hits, then we calculate what the refund is, and all the refunds kind of come and pile up here. And the idea is, eventually we haven't incorporated multi-sig, but the idea is the merchant can actually look at the refund and say, okay, you know what, this kind of makes sense. So instead of us auto doing the refund, the merchant can actually do the multi-sig and enable the refund, right? And there are a couple of assumptions we made just to make life easier. One is that you can have multiple addresses, right? So how do we know that the transactions that a merchant got are from the user or a vendor or a supplier, right? And the idea is, our assumption is the merchant will give an address for all the users, a different address for the vendors and suppliers, so that way it will be easier for us to mine the transactions. So we did two pieces of code. One's the liabilities and refunds. So just what we try to do is we try to figure out how can we get this data, and then build the code, which and we can also share some of the learnings, right? So for example, we went for this merchant. Let's look at all the transactions. Yes, transaction 1, transaction 2. Then we went for each of those transactions. What are the inputs? And assumption being the inputs are the actual user's transactions, and then we tallied up. We clustered it by a user ID to figure out all the transactions from the user, and that's kind of how we arrived at the refund amount. And you guys want to, Ajit, you want to quickly talk a little bit about how we calculated it? Or?
Yeah, so in a nutshell, what we're doing in the liabilities is once we do have a transaction or a user address, what we're doing is here we are going under the assumption that it's a constant user address. It's not going to change. And then we basically explore the blockchain and go through all the transactions made to this merchant and basically just sum up all the amounts. And finally, basically, this is what we get. So we've got this user making these are the amounts that have come to this particular merchant, and we've explored the blockchain on this particular merchant, and we've got these two keys amounting to these two amounts.
And then get us to the refund.
Go ahead. And refund is basically our API to send out the cashback, or in this case, bit back out to the user. So this is basically sending out a transaction.
Any learnings or?
So the learning curves, yeah, it's been a lot of, I'm primarily a Java developer, so I don't think in terms of asynchronous input output, so that was a bit of a learning curve, but it's been interesting. And another thing, the APIs that we've used out here is we started off using the bitcore.io, which is a great API. It's not straightforward, but it does get a little bit complicated, so for the refund we've used bitcore.io, and for the liabilities and for exploring the blockchain we've used BlockCypher.
And I think like when you start with anything new, right, it's just amazing, right? It's the small little things that can like hold you up for a long time, right? For example, we were stuck the first 1 week because we just couldn't get any transactions going, and we tried all sorts of things. We tried different APIs, and finally we realized that the address we generated was for the mainnet, and we were trying to test it against the testnet. We forgot that there's a version number that gets appended to your address, right? So that literally took away a good week from all of us banging our heads, right? And
So just to add on to that, if you're just testing out with testnet, the site to go to is basically blockr.io. That will actually give you the testnet addresses. So actually our addresses were correct. It was the display that was incorrect. The version. So.
And I think the other thing, going back to the APIs, one thing at least we learned is, while there's like the chain.code, the block.io, the BlockCypher, a lot of APIs, it really depends on your use cases, because certain APIs are much better for a certain type of things. And the good thing we found is we started doing mixing and matching of APIs, because at the end of the day, the transactions are on the network. It doesn't matter if you use BlockCypher API for some things, Bitcore API for something. So I mean, that's a key learning for us, which is say, it doesn't matter, we have to know only Cypher or use only Cypher, as long as we know that each one it's more geared for a specific use case. Just kind of go with that.
Another thing is basically what we learned is how do we really interact with the testnet, and how do we try to figure out because it's a very new learning for us, any transaction, how to go verify it and try to get the amounts and other details. So that's another new learning.
All right, guys, that's it. So,
Any questions?
any questions?
Oh, so you were able to use Bitcore to broadcast? Because I could never use their peer manager. I couldn't figure it out. I ended up having to go to another library. So how did you actually broadcast? Did you use Bitcore's peer manager function?
So inside.
Repeat the question.
Yeah. So no, we used Insight. So if you've used Bitcore, so there's a Bitcore which is a core APIs, and then there's Insight Explorer that's just on top of it. So we did install a local node, and then thought we could use a Bitcore to connect to the local node, but it just wasn't happening for us. So what we did is we used the Insight Explorer that sits on top of it, and the Insight Explorer talks to its test node for sending the network. But then for actual transaction exploration, we use a BlockCypher.
Yeah, and I mean, after this, we could just show you what we've done. So.
Oh, that'd be it.
Thank you.
Can you have them stand, like,
Yep.
because you guys are hiding.
The light here.
Wait, can you stand
Well, push on now, so we can.
together in a photo? I stand close together, guys. Thanks.